Hello again. Welcome to another lesson in geometry. Today we're covering Chapter 1, Section 8 about perimeter, circumference, and area. So our warm-up, use a diagram at the right to answer exercises 1 and 2. Find the length of a line segment AB. So we're going to use our distance formula here. So if you look in the book again, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And we need to find the coordinates for these 2 points so we can know our x2s and y1s and stuff. So B's is at negative 2, 2. And A's is at 1, 2, 3 over and 7 up. Let's see, 2, 4, 6, 7. Okay. All right, so let's plug them in. Remember, it doesn't matter which one you call x2 or x1. So I'm just going to start down here. We'll do negative 2 and 3 first. So the square root of negative 2 minus 3 squared plus, and then we'll do the y's, which I have to start with 2 now, and then 7. 2 minus 7 squared. So then this is equal to the square root of negative 5 squared plus negative 5 squared. That turns into 25 plus 25. And that's equal to the square root of 50. And then we write units on the end of this. Now, in some examples, last notes, we did estimating here, but this did not ask us to estimate, so the actual length is the square root of 50. Okay, that's around 7, so that thing is about 7 long. All right, find the coordinates of the midpoint of AB. So the midpoint was x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay. All right, so in this case, our x1 was negative 2, and our x2 was 3. So negative 2 plus 3 divided by 2. And our y1 was 2, and our y2 was 7. Okay. All right, so our midpoint is going to be equal to negative 2 plus 3, which is 1, and 1 divided by 2 is 1/2. And 2 plus 7, which is 9, and 9 divided by 2 is 4.5. All right, so the midpoint of this is going to be at 0.5 and 4.5. So 0.5, 1, 2, 3, 4, 4.5. And that's right in the middle, okay? Fortunately, it was on our line. It's a good way to check ourselves to see if we were wrong. All right, down below, a polygon, new definition here, is a closed plane figure formed by 3 or more segments. Each segment intersects exactly 2 other segments at their endpoints. No 2 segments with a common endpoint are collinear, so that doesn't make one big long segment. And each segment is now called a side. And where the endpoints are called vertexes or vertices. Okay? So for instance, this is a polygon. Each segment, AB, BC, CD, DE, AE, connect to the other segment at the same endpoints. Okay? And no 2 segments overlap or connect each other, cross over each other. This is not a polygon because A and B need to be connected. And this one's not a polygon because of this intersection of 2 of the sides. All right, so we have some common polygon names and for the number of their sides. Triangle you probably know. That's a 3-sided one. Quadrilateral you probably know. Pentagon you know. There's a very famous building about that. Hexagon is a 6-sided one. Heptagon is a 7, octagon is 8, nonagon is 9, decagon has 10, and then you need to know dodecagon, which is 12. After that, we just say like a 13gon or a 14gon or 15gon, where n is the number of sides. Okay? So there are some special names for some farther along ones, but these are the only ones that you need to be responsible for. Okay? Probably you'll have to do some memorizing from 9, 10, and 12. All right, let's flip it over and check the second page. There are 2 different ways to measure the size of a shape. Just different ways to think about the shape when we think about its size. One of them is perimeter, and the other is area. So the perimeter is the distance around a shape. So we could measure the shape size by how far does it take to walk around it. There's a special name if the shape is a circle. We call it circumference instead of perimeter. Area is measured by how many little square units it takes to fill the inside of the shape. So just 2 different ways to think about the size of a shape. Okay. All right, so we have to fill in some table stuff here. For a square, what would the picture look like? Well, a square is a quadrilateral where all of the sides are the same length and all of the angles are right angles. So that's what a square looks like. The area formula for a square is side squared. Okay, now you can use the formula for a rectangle for a square anyways. This L and W are the same number. The perimeter formula for a square is 4 times the number of sides. So to walk around this, we have to walk 4 lengths of side each. Okay. All right, rectangle. A rectangle is a quadrilateral, so 4 sides again. And what's special about a rectangle is opposite sides are the same. Okay. Not all 4 necessarily. So a square is a rectangle, but a rectangle is not a square. And it has all right angles. So an area formula for rectangle is A equals length times width. Length and width are the names we give for the 2 different sides. Okay. And then the perimeter formula is 2 lengths plus 2 widths. All right, we have 2 other basic shapes here. We have the triangle. Triangle is a 3-sided shape, okay? And the area of a triangle is given by this. Its base times its height divided by 2. So we find the area of a triangle by looking at one of the sides and then drawing the height in perpendicular to the top of the triangle, okay? And then we multiply them together and divide by 2. And then the perimeter for a triangle, okay, is equal to side 1 plus side 2 plus side 3. We need to know all 3 sides, okay? So to get the perimeter of a triangle, you have to actually add up all 3 of them separately. There's no special formula for it. All right, and then our last part is a circle here. A circle, we would need to know the radius usually. Okay, so the area of a circle is pi times the radius squared. And the circumference of the circle, we're going to have 2 formulas here, although they mean the same thing, get the same number. One of them is 2 times pi times the radius, and the other is pi times the diameter. And the diameter is all the way across the circle, so it's 2 radiuses. For exercises 1 through 5, the Botany Club members are designing a rectangular garden that is 18 feet by 22 feet for the school courtyard. They plan to create a stone path around the garden that is 4 feet wide. So draw a neat labeled picture of the garden and the path. So this is the garden part. And our garden is going to be 18 by 22. And then they're going to build a path around the garden. And the width of the path is going to be 4. Okay? All right, so find the area of the garden part. Okay? So the area of the garden is length times width because it's a rectangle, and the 2 sides are 18 and 22. So 18 times 22 makes 396 feet. Squared, because it's area, so it's how many little squares would it take to fill that up. Now find the area of the stone path. Now that part's a little bit trickier. The big blue part is, let's see, it's 4 here and 4 there. So this whole place from here to here is going to be 22 plus 4 plus 4. So that's 30. And the other way is found very similar. We're going to do 18 plus 4 plus a 4 over here. So 18 plus 8 is 26. Okay? So the area of the stone path is going to be the area of the whole thing minus the garden part that we don't want. That's how I'm going to go about doing it. And so that means I'm going to do 30 times 26 minus 18 times 22. Okay, so I found the whole big thing and then subtracted the garden part out of the inside. And that left me with just the path. So 30 times 26 minus 18 times 22 gives me 384 feet squared. So the path part on the outside, even though it's only 4 feet wide, is almost as much area as the whole garden. All right. Find the perimeter of just the garden. So the perimeter of the garden is going to be 2 lengths plus 2 widths. So 2 times 18 plus 2 times 22. So 2 times 18 plus 2 times 22 will give me 80. So it takes 80 feet to walk around the garden. So you walk 18, 22, 18, and then another 22. Find the perimeter of the garden, including the path. All right, so we already know how big it is on the outside of the path, so it's 26 by 30. So our perimeter is going to be equal to 2L plus 2W again, which is 2 times 26 plus 2 times 30. So 2 times 26 plus 2 times 30 gives me 112 feet. Okay, so the outside of the path, walking around that, will take you 112 feet to walk. All right. Okay, you can name a circle with the symbol, looks like a circle with a dot in it for the center. For example, a circle with center A is called circle A. A is the center. The formulas for area and circumference of the circles involve a special character called pi. It looks like this. You've seen this before. Pi is the ratio of any circle's circumference to its diameter. So no matter what size the circle is, if you measure its distance around versus the distance across the middle of it, you get 3.1415. Ooh, that should have a 1 in this, sorry. 3.1415926 dot dot dot. You cannot write it as a terminating decimal. Remember, this is an irrational number, goes on forever and never repeats. Therefore, exact answers will have the symbol pi in it. So in the past, you've probably been doing estimating of these when you found the area and circumference of circles. Now we're going to write our answers in terms of pi, and then we're going to round it afterwards. So what is the circumference of each circle in terms of pi? So circumference formula is 2 choices. We have 2 pi r or pi d. Since this is a diameter, I'm going to use pi d. So this would be 15 pi meters. That's the exact answer. And then we're asked to round it to the nearest tenth. So 15 times pi will give me 47.1 meters. All right. Our next one, we're given a radius this time, halfway across the circle. So our circumference is 2 times pi times r, which is 2 times pi times 4, or 8 pi. And this is inches in this case. Remember, circumference is perimeter, so that's distance around. It does not get a inches squared. It's not how many little squares fit inside it. All right, so to estimate this is 8 pi is about 25.1 inches. Okay, number 7, draw a circle with center K and mark its radius as 4. What is the exact area of circle K? So this is K, and it has a radius of 4 feet. All right, the exact area. So area is equal to pi times the radius squared. So that's pi times 4 squared, which is 16 pi, and it was feet, so this is going to be 16 pi feet squared. So this next one is a little bit of a long problem. Let's see why. All right, so 3, 6, we're going to find the triangle of the coordinates 3, 6, -3, -2, 3, -2, and we want to find that triangle's perimeter. So 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6 is right here. -3, -2, 1, 2, 3, 2 down, and 3, -2, 1, 2, 3, and 2 down. All right, so this is our triangle. And it's easy to see the distance for some of these. This distance, of course, is 6. And this distance is 2, 4, 6, 8. But that last one, I don't know. We're going to have to use the distance formula. So we're finding the distance between 3, 6, and -3, -2. All right, so we're going to have to use our distance formula to find that length, and then we can do the perimeter afterwards. So the distance formula is the square root of -3 minus 3 squared plus -6 minus 6 squared. And we work that out. That's the square root of negative 6 squared plus negative 12 squared. Negative 6 squared is 36, and negative 12 squared is 144. When you add those together, we get 36 plus 144 is the square root of 180. All right, it didn't tell us to estimate here, so this is a little trickier. So I know my perimeter is going to be equal to the three sides added together. So 6 plus 8 plus the square root of 180. Now, we can't add the square root of 180 onto the 6 and 8, so this just turns into 14 plus the square root of 180. That's our exact length. And it doesn't say what kind of units, so we write units. If we were going to round this, though, it would be about 27.4 units. Okay, but it didn't ask us to round, so this is really the good answer. 14 plus the square root of 180. All right, postulate 1-10, remember postulates we don't have to prove, and we haven't had to prove anything yet, is the area addition postulate. If an area of a region is the sum of the area of its non-overlapping parts. So what you can do is break up a non-regular shape, like if it's not a square, a rectangle, a triangle, one of the ones we have formulas for, into those kinds of shapes. So we take this irregular shape here, and we break this into like maybe 3 rectangles, or 2 rectangles in a square, actually. And then we can find the area of each one of those separately. So LW plus LW plus side squared. The first one here is 3 by 9. The second one is 3 across, because that's a 3, and then it's 6 down, because we subtracted off 3 of it. And our third one's a square, it's 3 by 3. All right, so we just add these up. So 27 plus 18 plus 9, and 27 plus 18 plus 9 is equal to 54. So this is 54 centimeters squared. So this postulate's important. It just says, hey, if it's not one of these you know formula for, just break it into shapes individually until you find what you do want the formula for. But be careful, you cannot make the shapes overlap each other. Okay? I also do one where we subtract from the whole. I like that trick a lot. We used it on the garden problem earlier. All right, I'll see you in class next time. We'll practice some area and perimeter.